Here is the diagram which shows how to use the testbed. In the first part, we will introduce the network topology constructed by Raspberry Pis. The network topology for this testbed is shown in the figures of the video. It is a very simple 4-switch tandem network with 2 flows. The flow passing all 4 switches is the flow of interest in the experiment. The network topology can be modified easily by changing the connection between switches and the number of switches. In the photo of the testbed, cables are connected if they have the same color of label. Ethernet port with orange label is connected to the receiver and the black cable with blue label is connected to the sender one. In the second part, we will measure the maximum end-to-end delay when there is only one flow existing. The flow used in this part passes all 4 switches, which is also known as the flow of interest in the next part. We can see that the maximum end-to-end delay is approximately 2.3 milliseconds. The average transmission rate of the flow is about 5.5 megabits per second. The third step is used to see the influence of the second flow on the maximum end-to-end delay of the flow of interest. We add a second flow, which is from sender 2 to receiver in the last switch. From the previous step, we know that the maximum end-to-end delay of the flow of interest is 2.3 milliseconds without other flows. In this experiment, we can see that the maximum latency of the flow of interest becomes 97 milliseconds, which increases dramatically after adding the second flow. To use the network calculus, a arrival curve of 2 flows should be calculated. In this part, we will calculate the arrival curve of 2 flows. The calculation is based on the definition. We use the average transmission rate as the rate of the arrival curve. The burst is searched by using binary search. The error of the burst is less or equal to 100 bits. Results are shown in the terminal. Here is an animation of searching the arrival curve. The red line is the cumulative curve of the packets. Blue and cyan lines are the 2 boundaries of the binary search. In the end, the 2 boundaries will converge to one line, which is the arrival curve we want. In this step, we will calculate the service curve of switches. We have conducted experiments on testing service curves of 4 switches. The result shows that the 4 switches have almost the same service curve because they have the same hardware and software. We use the bandwidth of the switch as the rate of the service curve and then search the latency using binary search. We let the flow of interest pass only one switch and do the calculation according to the definition. The result is shown in the terminal. Here is the animation of calculating the service curve. The blue line is the cumulative curve of the sender and the cyan line is the cumulative curve of the receiver. Red and yellow lines are 2 boundaries of the binary search. This is the last step of the diagram. We have gotten all the parameters we need for network calculus from previous steps, then we feed these parameters to Disco DNC. Since the switches use FIFO-Q, we can only get the result of TFA and SFA. We can see that SFA gives a much tighter maximum end-to-end delay bound than TFA, which is about 0.26 seconds. We measured the maximum end-to-end delay of the flow of interest, which is only 76 milliseconds. We can see that the delay we measured meets the bound calculated by the network calculus.